It's great to see all of you here, so let me directly tell you what you can expect from today's session. In the next 40 minutes, we will present you how Delivery Hero solve compliance requirements from a new legislation to prevent illegal working, and how they simultaneously reduce fraudulent behavior of account lending and account sharing using Amazon Rekognition. If you are a developer, you're right here to learn details into the architecture and code of Amazon Rekognition for identity verification. And if you're coming from a business role or product role, you will also learn insights on how you can accelerate innovation using AWS technology to react to a changing business. As Andy Jassy wrote in his last shareholder letter, change is always around the corner. Sometimes you proactively invite it in, and sometimes it just comes a knocking. But when you see it coming, you have to embrace it. Delivery Hero was facing a change in terms of a new requirement for identity verification and was looking for an automated and time and cost-efficient way to address it. Going forward, we will present you the innovation journey from the initial idea until the implementation. My name is Lisa Seehorsch. I'm a senior account manager at AWS, part of our digital native business team, be with Amazon since almost 7 years, and I do have the pleasure to be here on stage today with Roberto.
Good morning, everyone. My name is Roberto Ferraz. Thank you. I'm an engineer manager at Delivery Hero, and I'm very excited to be here today to share with you a bit about our journey together with AWS on this amazing success story. At Delivery Hero, I manage the rider access team, and the rider access team is responsible for rider authentication and account fraud detection. Before we jump into our topic of the day, I would like to give a quick introduction about Delivery Hero, as that is very important for us to understand how we reach this topic in the first place. So, Delivery Hero is a Berlin-based food delivery company. Our goal is to provide an amazing experience to our customers, a great, safe, and fair work environment for our riders, while making sure that our partners can focus on what they do best without getting distracted by technology or food delivery. We are currently present in 74 countries. Here you can see our beloved brands, for example, Talabat, Glovo, Foodpanda, among others. In the past 12 years of existence, Delivery Hero grew at an amazing speed and to a quite epic size. Let's dive a bit deeper into how we reached this scale. This is very important to understand the source of the problem that we solved. So, Delivery Hero was founded in 2011 in Berlin, and in the years that followed, many important things happened in the company. We expanded in Asia, Latin America, Africa, and Europe. In the many countries that we were present, we were very early on the number one in number of orders, active users, and number of restaurants registered with us. In 2017, we became a public traded company in the Frankfurt Stock Exchange. And in 2018, we reached our first 1 million order per day milestone. What does that have to do with a helicopter? Nothing at all. Basically, this is just an interesting story that happened in that year in Romania. We received a very unusual order from a city that was 150 kilometers far from Bucharest, where the restaurant was located. That order was basically a lunch order for more than 100 people. So it was no way that we would be able to deliver that order in time using a car, much less by bike. So we used the only way possible to do that. By midday, the helicopter left Bucharest with the order, and by 1 p.m., more than 100 people were having lunch. What does it have to do with anything we are talking here today? Not much, actually. This is to show that Delivery Hero actually, since very early moment, were very capable of complicated operations, and also, it's a very cool story. So, in the years that follow, we continue our expansion into other countries, until 2020, where the world basically changed. The COVID pandemic made basically everyone in the world change their behavior, and with that, we all started to rely more on delivery services. With that, we saw an increase from the 1 million orders that I just described to 3 million orders per day. The other thing that happened is that because of the health concerns and, of course, the amount of orders, we also started testing with different ways of doing the delivery. And here you can see one of them was delivery by drone. Our amazing Food Panda team playing with their new exciting toy, which I'm very jealous that we don't have one in Berlin. In the year that followed, of course, the COVID was still there. And with that, the demand for delivery service increased even further. And our order then reached from 3 million to 5 million per day in just 1 year. Because of that increase in all the years before, we of course had to keep scaling our team of riders in order to cope with that. It was also the year that we started testing with autonomous robots for food delivery. And here you can see our cute little robot called Dora in the streets of Sweden. So local teams that having helicopters, drones, robots, we are just jealous here in Berlin because we don't have any of those. Last year, we expanded further in the Middle East, in Africa, and in Europe. And with that, we increased the number of people that we cover around the world to 2.2 billion people. That's a lot of people, basically. And in order to be able to cover that population, we, of course, had to keep increasing our number of riders. And today we count with 1.4 million riders around the world. That's a lot of people as well. So, as you saw it, in the past 12 years, we grew to an amazing scale, and also in an amazing speed. Here you can see another cool photo of our riders using a jet ski to deliver to an island in Sweden. They really have a very cool job, I would say. And of course, with that growth, we can say that it's pretty much expected for any company to face operational challenges. And that's exactly what brings us to the beginning of our problem. Going back 1 year from 2022, the local teams start hearing from other riders, basically, that their colleagues sometimes were not working according to our code of conduct. By then, we were not aware of how big the problem was, or even what was the financial impact of it, so we started the problem discovery. With that problem discovery, we identified that there were at least mainly 3 types of account fraud. All of them had one thing in common: one account being shared with different riders. So let's talk about those 3 types of account fraud. The first one was an account sharing with the intention of financial gain. What does that mean? It means in one single country where we operate, we pay a reward for riders that work full-time. So it's a bit higher rate than we would pay to a part-time rider. And why is that? It's because in that country, we have a lack of full-time riders. So we want to basically attract more people to work full-time. So what happened was that some riders decided that, okay, I want to work part-time and actually get paid full-time. And how did they achieve that? They registered to work with us as a full-time employee, but actually they just work part-time. They found more colleagues with the same goal, and they share the same account. So for Delivery Hero, that account was a full-time employee, but in fact, the rider was working sometimes just a few hours, and all the riders were completing the shift. For Delivery Hero, in that single country, that cost us 50,000 euros per month. But that wasn't just the money loss, right? There was a fairness problem as well. As I mentioned in my introduction, we want to make a safe and fair environment for our riders. So riders that were working full-time and following, basically, being honest, let's put it like that, they were getting paid the part-time rate, while their colleagues were working the same amount of hours and actually getting more money than them. So that wasn't fair, and we did not want that to continue. The second type of account fraud that we can talk today is account sharing with the intention of defrauding Delivery Hero. So in some countries that we operate, we accept cash on delivery, meaning the customer makes the order and they pay directly to the rider in cash for that order. So what will happen is some people would then collect different orders, get all that money, and then disappear with the money, and Delivery Hero will never see that money again. Of course, what we would do, we would terminate that contract and say, okay, we are not going to hire that person anymore. But sadly, that was not the end of it. They would then find a friend, family member, and they would ask them to create an account for them. And then they would just use that account to repeat what they did many, many times without getting identified. That, in one single country where we did the discovery, the money loss was 200,000 euro per month. That was not a problem that happened in only one country. It happened in different countries, but that was the country where we did the discovery. So you can imagine a much larger amount of money being lost every month. Thank you. So the third and last type of account fraud is account sharing with the intention of evading labor and immigration law. I imagine that some of you already get the idea, but basically, a person that does not have the permit to work in a country, or even the permission to live in that country, in order to work, they would ask someone that they know to create an account to be a rider with Delivery Hero and share with them that account so they could work. Some people did that with the intention of helping a friend. Other people did that with the intention of actually exploiting illegal immigrant. So they would get paid and they would give just a small percentage to the person working. Either way, both definitely wrong. And it's, in fact, a violation in many countries to employ an illegal immigrant. And even worse, in some countries, we can actually lose our license to operate in case that is identified. So we had 3 types of account fraud, and we wanted to prevent all of them from happening. So we created what today we call the identity verification flow. In that moment, it was just an MVP. And how it worked. Before every shift, the rider had to take a selfie, and that selfie would be then sent to our backend service. And later, maybe the same day, maybe other day, someone in the local team would manually verify that photo. They would get the photo, they would go to the passport or visa of that person, and they would see, okay, is that the same person? If it wasn't the same person, they would then take action on it. Depending on the country regulation, they would issue a warning. Depending on the type of fraud, they would suspend or terminate the contract. In the beginning, of course, that helped us reduce the number of fraud to a bit smaller size. But as we started to enable this feature to whole countries or different countries, that became quickly a problem. In a couple of months, the number of photos that we receive every day was 50,000 photos. So there was no way that manual verification would cover that amount of photos every day. So what they did is they would randomly select riders to check, and then all the others would be basically ignored. Of course, the users quickly identified that was the case, right? One day, 1 or 2 riders sent a photo that was invalid, a photo of the floor or a photo of another person. Nothing happened. So they told their friends, look, maybe nothing happens if you do that. And their friends did that. In 1 month, 80% of all photos that we received had no face on it. It was a photo of a car, a photo of the sky, of the floor, and so on. So for the rest, 16% of the photos were actually valid. So it was a lot of photos, a lot of useless photos, and we were poorly using the time of our local offices. So we knew that we had to create an automated solution to solve that problem, right? And that's exactly when we reached out to our partners at AWS to help us create a better solution.
Receiving the request from Delivery Hero at that time, we from AWS were of course happy to support and started to write down the business impact, including all of the requirements Delivery Hero had, from cost optimization, level of automation, until the complexity of the solution. And we will do a deep dive into requirements later. While working on this document, we got interrupted by an important and urgent change. The labor minister of the UAE, the United Arab Emirates, reached out to all companies with a fleet, including Talabat, the company of Delivery Hero operating in the MENA region, and shared with them an upcoming legislation with the goal to prevent illegal working. The legislation expected an automated solution for identity verification, which must be in place in just 6 weeks. If not compliant with the new law, Delivery Hero would have risked a fine of 13,000 euros per rider if they get caught by the police and couldn't show a successful verification in their app. In the UAE, Delivery Hero would have risked a fine of 5.2 million euros a year. So we needed to act quickly, even though this was not planned initially. With a small team of just 4 engineers at Deliver Hero, we all work together as one team with one shared goal, to deliver this in time. So we started to review the requirements again, to making sure that we incorporate the legislation details. And after a few meetings, Deliver Hero made a decision to choose Amazon Rekognition. Deliver Hero also completed the technical implementation of Amazon Rekognition in the required 6 weeks and directly rolled it out to the UAE. Until now, Amazon Rekognition for identity verification is used by Deliver Hero in 28 countries and is processing more than 250,000 pictures on a daily basis. And companies like Foodpanda in Asia or Pedidosia in Latin America are already using that technology. Let's do a deep dive now into the requirement specification, the impact of the UAE law, and also some technical details. Starting with the requirement specification. The goal from Deliver Hero was to go from a manual solution to a full automation. And you can see in the slide that we are comparing the requirements from Deliver Hero directly with Amazon Rekognition. One of the most important requirements for Deliver Hero was a simple data and process management. It was paramount to assure that everybody in the team can work with the technology and it can be easily rolled out to other locals without a long training phase. Additionally, it had to contribute to the return on investment with a good cost efficiency, a fast deployment cycle, and a low maintenance effort. And finally, Deliver Hero wanted to focus on innovating on behalf of their customers and spend as little time as possible on the code and setting up the infrastructure. Taking a look at all of these requirements together, I actually have a question for you, Roberto. Can you please tell us how you proceed with all of these requirements?
Sure, thank you for the question. Yeah, basically, as I mentioned, right, we had a time constraint. Not because of the UAE alone, but as I was describing, the feature was becoming basically useless by the volume of useless data, basically. So we first considered what would be the quickest solution. And the quickest solution maybe would be using an out-of-the-box solution instead of writing one ourselves. So we look into a couple of solutions out in the market, and we identified a couple of problems for Deliver Hero, not with the solution itself. The problems could be, as those solutions are meant to attach to different companies and different use cases, they would maybe require too many changes in different services of Deliver Hero to fully integrate and provide again, sorry for the word solution, of that problem. The second issue was that given the complexity of those tools, writing a POC to validate that they would actually help us wasn't that fast, right? We would need, first of all, sign contracts and go through procurement and then time of development, and we did not want to do that. We wanted a quick way to verify that it would actually work and solve our problem. The third and last problem that we identified was data privacy. Many of those solutions required us to send write data to them beforehand, especially photos. And it was a very tricky position for Deliver Hero to be, given that we are very concerned with data privacy, to share write data with the company before knowing full well that that would actually be helpful for the riders and for the company. So with those concerns, basically, we saw that it would be a better idea to develop a tool ourselves. We were already aware of Amazon Rekognition, but nobody in our teams had experience with it. So I decided to do a POC myself to verify that it would actually work for us. In maybe 1 or 2 hours, I managed to write a small POC that would get the image from an S3 bucket, run through Rekognition, and store the result in a database. That's not the solution we have today. We are going to look into that later. But basically, with that simple solution, with 1 hour, we were able to validate that Rekognition would actually solve our problem and would not require a lot of development time and so on. So.
Thank you, Roberto, for providing the insights. Let me quickly summarize the main benefits that Roberto mentioned. With Amazon Rekognition, Deliver Hero gets access to a fully managed and innovative face analysis tool with ready-to-use resources that are reducing their operational time for implementation and offers a rapid integration with other AWS services through APIs. And this all with a pay-as-you-go model. So when we were in this process to review the requirements, that was actually the time when the final version of the UAE legislation was released. So we reviewed the requirements, making sure the legislation details were included, but we saw that one requirement changed in terms of the priority: the time to results. You might have the similar questions that we had during this project. How fast can we implement Amazon Rekognition? Can we do this in the required 6 weeks to prevent million euros of fines? Let's take a look how the architecture looks from a rider perspective and also the technical details to answer those questions.
Thank you. So this is the current active in production version of our application. Let me step here so I can show you around. So the first screen that the rider sees is basically, of course, instructions and privacy policy. It's very important to understand what we are doing with their photo. Then it's very simple. They position their face in the frame. They review the photo. If it's good enough, they like it. And then after they send, the screen is closed and they can proceed with their activity. We do not give them a positive result or a negative result of their facial recognition. The reason why we don't do it is basically we want to make sure that the rider can start working as fast as possible. We don't want to create hassle for the rider. So that's why you get the photo, you send it, end of story, you continue with the application. The only case we receive a message is in case the rider tries to send a photo without a face. As I mentioned in the beginning, we had 80% of photos without a face, so we just want to validate that early on and let the user know that that's not allowed. In any other case, the feature closes and they proceed with their shift as normal. So let's look into the architecture and see how we actually implemented that solution. So don't worry, you don't need to try to read all of it. We are going to look that into parts, but just wanted to give a whole picture of our architecture. Our journey starts in the rider application. The rider application, as I just showed, the rider takes a selfie before the shift, and then it sends that selfie to our services. The rider access service is responsible for authentication and fraud detection. We receive that photo, and the first action that we do is to store the image in an S3 bucket. That image is going to stay there for 90 days. And we do that in case we need to refer that back to that image for legal reasons, but also for the solution itself. After the image is stored, we then run a face detection using Amazon Rekognition. We do that again to prevent that we have a lot of photos without face on it. If the photo has no face, as I just showed, we immediately send an HTTP error to the front end. We show a message, and then the flow is over. Nothing else happens after that. If the photo does have a face, though, we continue. And the way we continue, basically, is we go to the rider document service you see there in the corner. That service, as the name says, stores documents of the riders. For example, passport, working visa, and the most important for this feature, basically, the photo that's taken from the rider the moment they register to work with us. For example, a worker ID. That is the photo that we are going to use from that moment on for validating that the selfie that we receive is of the same person. And we do that using Amazon Rekognition. So we get those two photos, we send to Rekognition, and we ask, is that the same person? And with that result, we then proceed. You might be wondering, if you are a software engineer, how complicated is that and how much code you need to do that? So let's look into this. Again, you don't need to read the function because we are going to break that into parts. But basically, this is all you need to detect if a photo has or not a face. This is in Kotlin, by the way. So this is the most important part of our code. We create the request, detect face, very, very easy name. We build it, and then we send attributes. What are those attributes? Those are what is the gender of that person in the photo. Are they wearing glasses? What is the hair color? And what is the mood of that person? They're angry, they're sad, they're happy. So all of these you can ask Rekognition and they will return it to you. For our presentation here, I just went with the simple way, just return all attributes that exist on AWS. The next thing that we do, we pass the image, basically. Here we call the source image, and the request is done. Just build it. Then you go to Rekognition, and you send the request that you just created, and you receive back an array. And why we receive an array? Because a photo, of course, can have many people in it. For our use case, of course, we are only interested, is there a person in the photo? So we just check if the array is not empty, and that's the end of it. Of course, if something went wrong, you send a PDF instead of a photo, for example, you get an exception, and then you do your magic according to your business rules, and end of story. So as you can see, detect face, very fast. You read the documentation, maybe 10, 15, half an hour if you write unit tests, which you should, but it's extremely fast. Compare faces, again, no need to read in detail because we're going to break it, is as simple. As you can see from the beginning, we do a very similar flow. We create a request, right? At this time, you need, of course, to pass two images, the image that you want to compare against and the selfie. And then you see here similarity threshold. What does that mean? Maybe according to your use case, you are only interested in high confidence level results. So you can tell Rekognition, I'm only interested in above 80% confidence level or 99% confidence level. As a delivery hero, we are interested in knowing if it did not match, and if it did match, we pass 0, then it will receive every single result of the Rekognition. Then you build a request, and you send it. And again, we receive, as a result, an array. As for our use case, our riders should, of course, send always photos with only one face. We don't need to go through the array. So we just return the first result. And from that result, we get the similarity and the confidence level. Again, if the file is wrong or you send a file without a face, we're going to get an exception. You do your magic, you log it, and then that's the end of it. So as you could see, implementing Rekognition in our use case, it was extremely fast. Maybe, I don't know, a couple of hours because we had to, of course, write tests, integration tests, and so on. But the most of the time that we use in our solution was actually focused on our own business logic, not on Rekognition. Rekognition allow you to do all of the tasks that you want extremely fast and with a very minimal amount of code. So with the result of Rekognition, we then do three things. First one, we go back to the image that we added to the S3 bucket, and we retag it. We tag that image, okay, now that image is successfully verified, or it failed. Why we do that? We do that for later to not go to the write the document service. We can just retrieve our own image in the S3 bucket. And then with that, you decrease the load of requests in a separate service, and also maybe latency as well. The next step that we do, we go to RDS and we store that data. That is for business intelligence and for defining strategy for the future in case needed. The third and last step is sending that result via SNS SQS. We do that, and any service that is interested in that result can just listen to that queue and get that result. Here you can see the compliance service, which is, in my opinion, the most critical service in the whole solution. Why is that? It is because it holds all the rules that the riders need to follow in order to work with us. The time to start working, in this specific case, of course, a photo that they send needs to be of themselves, right? And they should have a face on it, and so on. So all the rules in the company, not just about face recognition, for the riders are in those services. Also, what it is in this service is the action that will happen in case they break any of those rules. Those actions could be a warning message. They could be a suspension for amount of hours, amount of days, months, or it could be, in the worst case, a termination of contract. All of this is done automatically. You receive the message, it processes, suspend the rider, send a warning, terminate the contract without any human interaction. So, of course, to make it clear, we only send violations to that. You don't send successful. Okay, facial recognition is success. We don't go there, right? So if there is a violation of that rule, the first thing that compliance does is, again, publish that for any service that is interested in that information. Here we can see the shift service, as the name says. is the service responsible for giving shifts to riders and, of course, orders. If the rider has an active shift, that service will then terminate that shift and send any pending orders to another rider that's not suspended. If the rider does not have an active shift, they will try to get a shift by calling that service, and they will get an error message saying, okay, you are suspended for this amount of hours because of this reason, and that's why you cannot start your shift. The other thing that the compliance service does is send a message, regardless if it's just a warning or a suspension or a termination, letting the rider know what just happened. So that's also one reason why we do not, as a service, rider access in this case, we do not send recognition results to the rider because the compliance service will do that for us. So that is the whole architecture of our solution. As you can see, it is indeed extremely simple to use Rekognition. Most of the time that we use from the 6 weeks that we had, we used 4 weeks for development. And those 4 weeks, of course, were about integrating, creating resources, and deciding rules, and, of course, teaching the local team how to set the compliance rules and so on. And of course, revisiting metrics and making sure that we are complying with all the requirements of the feature. The last remaining 2 weeks of the 6 weeks that were given to us by the UAE government, we use, of course, for manual testing, and then gradually rolling out that feature to a small amount of riders to make sure that nothing was crashing. So at the end, of course, the results were amazing, and Lisa will have the pleasure to present to you.
I agree with Roberto. The results were amazing. Delivery Hero is now using Amazon Rekognition for identity verification in 28 countries and is processing 250,000 pictures on a daily basis. And this with a success rate of 97.38%, compared to the 16% with the previous manual verification. Previously, 80% of all pictures did not contain a face because no action happened. And we reduced this to 0.1%. And the cases when the selfie doesn't match the picture was reduced from 4% to 2.52%. In the compliance area, Delivery Hero received a congratulations and thank you letter for the UAE government for launching a solution before the deadline. Delivery Hero is now preventing 430,000 euros of monthly fines because they take action directly before a shift can start. And this number is also in line with the forecasted 5.2 million euros. Regarding the other types of fraud Roberto mentioned earlier, Delivery Hero is now saving 250,000 euros on a monthly basis, and this in just 2 countries. And even those numbers are great, we do not stop here, and Delivery Hero will further improve their solution with a smarter verification. We want to reduce the distraction for compliant riders and make the request of the identity verification random, and not only at the beginning of a shift. Delivery Hero will also implement the new Amazon Rekognition face liveness feature, which analyzes a short user selfie video to detect whether the user is real or if it's just a picture of a picture. And finally, Delivery Hero will implement a feature to detect if the rider is wearing a helmet in order to contribute to the company-wide goal of creating a safe environment. With this, we are at the end of our presentation, and I want to thank you for your attention.
Thank you.
We hope you did not only learn details about the architecture and code of Amazon Rekognition for identity verification, but also how you can drive innovation and support change using AWS technology. We all know that technology makes innovation possible, but we should not forget that it's the people. It's us in this room who build a better tomorrow. So if you're working on a similar use case, feel free to reach out to Roberto or myself, but share your story with the world. We will be also available for a Q&A in front of the keynote hall outside in the information desk. So if you have questions, please come and join us. A case study of Delivery Hero using Amazon Rekognition will be also published in the second half of the year, which you will find on the AWS AI Use Case Explorer. Thank you. We're looking forward to have a chat with you in a few minutes and wish you a great and successful rest of your summit day.
Thank you.